The first time humans saw this thing, they thought the ocean floor was rising. That's not a metaphor. Early sonar operators were watching their screens when a strong echo appeared where the bottom absolutely should not be, hundreds of meters above the real seafloor, like the seabed had lifted up to meet the ship. Then the echo moved up at night, down in the morning. The shocking, true part, it wasn't rock. It wasn't sand. It was a living layer so dense and widespread that it reflected sonar like a solid boundary. A phantom bottom made of fish, shrimp, squid, and drifting animals, moving together on a schedule. And most people scroll past this and miss what it means. A huge part of the ocean's life is literally hiding in plain sight, because your eyes can't see it, but sonar can. We're going down to about 700 meters, deep enough that daylight is weak and blue and unreliable, deep enough that the ocean becomes a three-dimensional night, and deep enough that your brain starts to believe the water column is empty. It's not. And today we're answering 5 questions that make this false seafloor feel impossible until you see the rules. How can sonar see a bottom that isn't there? What is the deep scattering layer actually made of? Why does it move up at night and sink by day? How did it hide one of the biggest migrations on Earth? And why does this layer matter so much that it affects fishing, carbon cycling, and even how we measure the ocean? By the end, you'll never watch a deep ocean clip the same way again, because you'll realize the darkness is crowded. Let's drop. Imagine you're on a research ship at night, not a movie ship, a real one. Steel deck, cold air, instruments humming. Somewhere below you is deep water, thousands of meters in many places, but you're focused on what's happening in the first kilometer. The sonar technician pings the water. A pulse of sound goes down, spreads through the ocean like a flashlight beam made of pressure waves, and then comes back as echoes. Most people think sonar works like a camera. It doesn't. A camera needs light. Sonar needs contrast. Sonar is basically asking the ocean a question. What down there reflects sound back to me? If the answer is solid seafloor, you get a strong return. If the answer is nothing much, you get weak speckly noise. But then you see it. A thick, bright band in the data, an echo that looks like a hard boundary, a floor. Except you check your depth and you're nowhere near the seafloor. This floor is floating in mid-water. And even weirder, over the course of the night, it rises. Then near dawn, it sinks again. It's like the bottom is breathing. This is the moment ocean science had to swallow something uncomfortable. The ocean was not empty space. It had a hidden architecture, a living horizon. That hidden horizon is commonly called the deep scattering layer. The name is technical, but the idea is simple. It's a layer of organisms that scatter or reflect, sound strongly enough to show up on sonar as a distinct band. And it can be big. Not big like a school of fish near the surface, big like spanning ocean basins, big like changing the entire meaning of the word empty. Now, why 700 meters in the title? Because in many regions, depending on time of day and local conditions, a big chunk of this layer sits in the mid-water, often in the few hundred to about 1,000-meter range, especially during daylight, when animals are hiding deeper. Around 700 meters is a perfect mental anchor, deep enough that sunlight is fading hard, shallow enough that nightly movement toward the surface is still plausible, and right in the zone where sonar phantom bottom readings can be dramatic. But keep one thing in mind. The exact depth varies by region, season, water clarity, predators, and even moonlight. The important part is not the number, it's the behavior. It moves. Let's make the ocean's layers feel real, because the deep scattering layer makes more sense when you understand what deep means in the open water. At the surface, the ocean looks like a skin, a boundary between air and water, but most of the ocean is not boundary, it's volume. And that volume is stacked into zones that aren't marked with signs, but are real in how they shape life. At the top, sunlight fuels photosynthesis. That's where the food chain begins. Go down a few hundred meters and you enter the twilight zone, the last place where sunlight still matters. It's dim, but it exists. Animals here have to deal with being seen from above and silhouetted. Deeper still, around the mid-hundreds, sunlight becomes so weak it's not useful, but it's still present enough to create a faint glow overhead. And then you hit the level where the ocean becomes psychologically different. Because now your eyes stop being good tools. You can have a powerful spotlight down there and still only see a tiny bubble of space. Outside that bubble is blackness, so we assume blackness means absence. But the ocean doesn't care what our brains assume. Now here's the trick of the deep scattering layer. It hides life by living just outside the range of your normal perception. You could be floating in a submersible at 700 meters, looking out into dark blue water, and you might see almost nothing. Maybe a few drifting particles. A distant silhouette, a flicker of bioluminescence, and you might conclude the water column is empty. But if you had sonar running, you'd see the truth. You are inside a crowded layer of organisms, some tiny, some medium-sized, some fish, distributed through the water like a living cloud. It's the difference between a flashlight and radar. Flashlight shows you what's in the beam. Radar shows you what's out there, even in darkness. Sonar is the ocean's radar, and the deep scattering layer is what it reveals. So what does sonar actually see? Sonar sends sound pulses and listens for echoes. Sound reflects when it encounters something with different acoustic properties than the surrounding water, differences in density, compressibility, structure. Solid seafloor reflects strongly because it's a hard boundary, but living organisms can reflect strongly too, especially if they contain gas. And that brings us to one of the most important details in this story: swim bladders. Many fish have swim bladders, gas-filled organs that help them control buoyancy. Gas is a huge acoustic contrast compared to seawater. That means a fish with a swim bladder can be an excellent sonar reflector. So if you have a layer packed with small fish that have swim bladders, sonar can light that layer up like it hit a wall. That's how you get a phantom bottom. Not because the sonar is broken, because the ocean is crowded with reflectors. And it isn't just fish. Many crustaceans and squid scatter sound as well, though fish with swim bladders can be especially influential for acoustic returns. So the deep scattering layer is one thing. It's a community, a mixed crowd of mid-water life, thick enough to fool our instruments into thinking it's a boundary. Now, why does it move? This is where the ocean becomes a story about fear, because the largest daily movement of life on Earth is driven by something simple: avoid being seen. Most of the animals in the scattering layer, especially the smaller ones, want to feed closer to the surface where food is richer. That's where plankton and smaller organisms are most available. But the surface is also dangerous because daylight makes you visible. So the rule becomes: feed higher at night. Hide deeper during the day. This is called Diel vertical migration, daily up and down movement through the water column. And it's one of the most astonishing behaviors on the planet because it happens on massive scales. Not one herd, not one flock, a planetary layer of life commuting. When the sun goes down, the layer rises. When the sun comes up, the layer sinks. That's why sonar operators saw the bottom move. It was life moving. Let's make that feel cinematic at 700 meters. Picture yourself in a deep submersible, hovering in twilight darkness. The water around you is not black like space. It's dark like deep ink, still a medium, still full of particles, still heavy. Your lights reach out and reveal a narrow cone. Everything beyond the cone is unknown. Now imagine the ocean at dusk. Above you, light is dying. Not instantly, but minute by minute. The surface is switching off, and as it switches off, something begins to change around you. At first you notice more faint flashes, bioluminescent pinpricks that drift in and out of view. Then you see small shapes moving upward, tiny fish-like silhouettes, shrimp-like forms, jelly-like drifters. It's not a stampede. It's a steady rise, like a crowd leaving a stadium through every door at once. And if you could zoom out, if you could see the water column in one frame, you'd see it as a thick band of life climbing toward the surface. That is the false seafloor moving, not the bottom of the ocean, the bottom of your assumptions. Now let's talk about the phrase in your title, the layer that tricks sonar. Because this layer doesn't just trick sonar in a cute way. It can affect navigation, mapping, and early interpretations of the ocean. Historically, sonar is used to measure depth. If you send a ping down and get a strong return, you assume it's the seabed. So when operators first encountered strong echoes from a moving layer, it caused confusion. It was a phantom, a false reading. But that false reading turned out to be one of the greatest accidental discoveries in oceanography. The midwater is not empty, and the deep scattering layer is not a rare anomaly. It's a global phenomenon. Now, what's actually living in this layer at around 700 meters? It depends on region, but typically you can expect a cast like this. Lanternfish small, often bioluminescent fish that are extremely abundant in many oceans. They're famous for being a huge component of midwater biomass and for migrating. Krill and shrimp-like crustaceans some migrate daily. Many are central to ocean food webs. Squid, some midwater squid species rise at night to hunt. Gelatinous drifters, salps, siphonophores, jellyfish relatives, often overlooked because they're delicate and hard to sample but important. Copepods and zooplankton. Tiny, numerous, and easy to ignore until you remember numbers matter. And layered through this are predators that track the movement, animals that know the schedule. Because if prey rises, predators rise too. The scattering layer isn't just a buffet moving upward. It's a moving battlefield. If you want the emotional core of this episode, it's this. The deep scattering layer is a reminder that our senses are not built for the ocean. A human eye sees a narrow range of light. A human brain assumes darkness means emptiness. But sonar doesn't care about light. Sonar cares about reflectors. So sonar revealed what our eyes could not, a living horizon. And once you understand that, you start realizing how many empty, deep-sea videos are actually showing only a tiny fraction of what's there. Because the camera sees only what the light touches. Everything else is off-screen life. Now let's connect this to "it hid life in plain sight." That phrase sounds dramatic, but it's literally accurate. The scattering layer was always there. It was hiding in plain sight in the sense that it was present in the ocean, moving daily, shaping food webs, yet humans didn't perceive it. Not because it was invisible to all tools, but because we didn't have the right tools. Once acoustics became widespread, the layer became obvious. And then the next shock happened, when scientists realized just how large the migrating biomass might be. Not just lots of fish. Potentially a major fraction of midwater life, moving daily. This matters because the midwater zone covers huge areas of the planet. The ocean is most of Earth's surface, and the water column is deep. So even moderate density of life across that volume becomes enormous. This is why you'll often hear that Diel vertical migration is one of the largest migrations on Earth. And it's why calling this a false seafloor isn't just poetic. It behaves like a boundary in acoustic data. It's a moving biological horizon. Now, here's where the story stops being a cool fact and becomes "this changes everything." Because the deep scattering layer is part of the ocean's carbon and energy movement. If you've ever heard about marine snow, the constant rain of organic particles falling into the deep, this is connected. The scattering layer animals feed nearer the surface at night, then return deeper and metabolize there. That means they move carbon downward through respiration at depth, waste products sinking from deeper levels, occasional death and sinking, packaging of particles into fecal pellets that fall faster. That daily movement is part of what scientists refer to broadly as the biological pump, mechanisms that transfer carbon from the surface to deeper waters. So the deep scattering layer isn't just a neat sonar artifact. It's part of the ocean's climate machinery. And it's part of why the deep ocean is not disconnected from the surface. The surface feeds the deep stores and transforms, and the scattering layer is a conveyor belt connecting them. Now, you might be thinking, if this layer is so important, why don't we talk about it more? Because it's hard to visualize. A whale breach is visible, a reef is visible, a shark is visible. A migrating layer 700 meters down is not visible unless you have the right instruments. And because most people engage with the ocean through surface experiences, beaches, boats, fishing from shore, we rarely think of the water column as a habitat. We treat it like empty space between the surface and the bottom, but the scattering layer proves the opposite. In many regions, the midwater is more like a city at night, not bright, not obvious, but full of movement. Let's go back to sonar for a second because the trick sonar angle is where your title grabs. Imagine you're mapping the seafloor. You're using echo sounders to measure depth continuously. You expect a stable seabed return, but now your system shows a strong return at, say, 500 meters. Then later it's at 300 meters. Then near dawn it sinks again. If you didn't know about the scattering layer, you might think your system is malfunctioning. Or you might think you're crossing an underwater ridge. Or you might think the ocean bottom is shallower than charts indicate. That's why early encounters were confusing. But once you realize the returns are biological, you can interpret them. And then sonar becomes more than a mapping tool. It becomes a life detector. Now, how do scientists study this layer today? They combine tools, acoustics. Different frequencies can detect different types of organisms and sizes. By comparing returns, scientists can infer what's present and estimate biomass. Net sampling, tough in deep water and often biased. Nets miss fragile gelatinous creatures and fast swimmers, but still used. Optical systems, cameras, laser imaging, low-light sensors, limited by visibility range but helpful for identifying organisms. Tagging and tracking. Some fish and predators are tagged to understand how they move relative to the layer. Oceanographic measurements, light levels, temperature, oxygen, currents, because the scattering layer's depth and behavior can depend on environmental conditions. And one of the most important scientific insights is that the layer is not always a single smooth band. It can split into multiple layers. It can be patchy. It can thicken and thin. It can respond to moonlight, to predator presence, to oxygen minimum zones, to seasonal changes in surface productivity. So the scattering layer is not just a thing. It's a living indicator of ecosystem dynamics. If it shifts, something in the system has shifted. Now let's address the depth again, 700 meters. At 700 meters, many parts of the ocean are deep into twilight or even effectively darkness, depending on clarity. That zone is a classic hiding depth for many migrating organisms during the day, because light from above is weak enough to reduce visibility to predators. But predators exist here too, and that creates one of the most interesting parts of this story. The scattering layer is not just prey. It's a moving structure that predators exploit. Some predators position themselves above or below the layer, attacking into it. Some ride it upward at night. Some pick off stragglers. And because so many animals in the layer have evolved to avoid being silhouetted, you see incredible adaptations. Bioluminescent counterillumination to erase shadows, big eyes tuned to faint light, transparent bodies, reflective tissues, deep red or black coloration that disappears in blue water. The ocean at 700 meters is not a simple environment. It's an arms race staged in dim light. Here's a wild thought that stays grounded in reality. If humans could suddenly see well at 700 meters without lights, if our eyes worked like deep-sea eyes, the ocean would feel crowded and busy in a way that would probably scare us. Not because everything is trying to eat us, but because we'd realize we've been living with a false mental model. We'd realize the ocean is not a surface with a bottom. It's a layered biosphere, and the deep scattering layer is one of its biggest moving pieces. Now, this is where the people scroll past this psychology hits. Because a lot of deep-sea content online focuses on extremes, the biggest squid, the weirdest fish, the deepest trench. Those are great, but they can accidentally create a misleading impression that the deep ocean is mostly empty except for rare monsters. The scattering layer is the opposite message. The deep ocean is full of normal-sized animals living in enormous numbers. Not monsters, not myths, just millions of small lives that add up to something huge. It's less cinematic at first glance, but it's arguably more important, because it's the midwater engine that connects surface production to deep ecosystems. So when people scroll past a sonar image of a band in the water column, they miss the real headline. That band is alive. Let's talk about the phantom bottom experience again, because it's too good not to. You're a sonar operator in an era when we're still figuring out the ocean. You ping. A strong return comes back. You mark it as bottom. But then it moves. It rises. You ping again. It's higher. You ping again. It's higher still. You think the bottom can't be moving. And you're right. But something is reflecting sound like a bottom. So you have to choose what to believe, your assumptions or your data. This is how science moves forward, not by having perfect tools. By having tools that show you something weird enough that you're forced to ask new questions. The deep scattering layer is one of those forced question discoveries. And it's one of the reasons the ocean still feels alien. It contains enormous structures made of life, not rock. Now let's add a layer of realism. The scattering layer is not just one uniform migration everywhere. Some species migrate hundreds of meters daily. Some migrate less. Some do reverse migrations in certain contexts. Some stay at depth. And in some areas, oxygen minimum zones can trap animals in specific depth bands because they can't tolerate low oxygen below or above. So the false seafloor is the visible signature of many behaviors overlapping. It's a crowd pattern. And that's why it looks like a solid line on sonar, even though it's made of individuals. Now, let's connect this to the human world in a practical way. Fisheries. Many fishing operations target midwater species, and understanding where biomass layers are can influence where and when fishing occurs. Also, if your sonar returns are influenced by scattering layers, you have to interpret your data carefully so you don't confuse biological returns with physical boundaries. It matters for navigation, for mapping, for resource management, and for ecology. Even if you never touch sonar, this should change how you think about where fish are. Fish aren't just near the surface or on the bottom. A huge amount of life is suspended in the middle, structured into layers, moving daily. That's the hidden architecture of the ocean. Let's do one more cinematic pass, this time as a full night story at 700 meters. You drop in late afternoon. The water is dark blue. Your lights reveal a few scattered animals, but it still feels empty. Your sonar shows a band above you. It's there, but it's deeper. As dusk approaches, you notice the band slowly rising. It's not a sudden jump, it's a steady climb. As it rises, the water around you becomes more active. Small flashes, tiny silhouettes, more movement. Then night fully arrives. The band is higher now. Some animals have moved toward the surface to feed. Predators follow. You see chase flashes, quick bursts of bioluminescence as something darts and something pursues. Then, hours later, you feel the shift again. Not in temperature, in behavior. The band starts sinking. Like a city turning off lights and going quiet before morning. By dawn, it's deeper again. And if you didn't have sonar, you might never realize an entire world passed through your depth while you watched. That's why the layer hid life in plain sight. It was always moving. We were just blind to it. So what's the takeaway? Here it is, clean and real. At around 700 meters, there is often a living layer in the ocean that reflects sonar so strongly it can look like a false seafloor. This deep scattering layer is made of countless organisms, fish, crustaceans, squid, zooplankton, many of which migrate upward at night to feed and sink back down by day to hide. It fooled early sonar into reporting a phantom bottom because sonar detects acoustic reflectors, not rock. And once you understand it, you realize the ocean isn't just surface and seafloor. It's stacked with life. It's layered. It moves. If you enjoyed this kind of deep ocean reality, real phenomena that sound impossible until you understand the physics and biology, hit like and subscribe, because this series is going deeper, one true anomaly at a time. And next episode, we can connect this moving layer to the deep seafloor in a way that feels even more haunting. The daily snowfall of marine snow that feeds abyssal life, and how the scattering layer helps move that energy downward like a living conveyor belt. But for now, remember this. In the deep ocean, the biggest secrets aren't always hidden in trenches. Sometimes they're floating right in the middle, so massive they can trick machines, and so common we learn to ignore them, until sonar forced us to see what was there all along.